So do you ever talk to them about AI? Because I know for a fact that my father never understands anything that we're doing. So he thinks we do like computer Excel and maybe some glorified Word documents.
No, I've had a lot of discussions with my dad about AI. I think it's mostly me disappointing him, kind of. But
so did you ever tell him that you'll replace him at some point in time? Or?
No, quite the opposite. So what I'm always saying is that I believe that at most AI will have the capabilities of a typical human being, maybe with virtually unlimited memory capacity and computation speed. But otherwise, I don't think it's going to supersede what humans can do.
So you never think about, you don't think like super intelligence is something that could ever manifest itself into our world?
So what would you define as super intelligence?
So I believe that super intelligence is when machines are able to set their own purpose and set their own wants and basically are able to realize the gaps they have in their knowledge and really go and learn, for example, how to do marketing from Coursera. And they would subscribe to a course and they understand everything about marketing, and then they market different products to us and we just buy them. And they understand how to control human beings and basically sell them different political agendas, different products. And we are very much, we are super unaware that machines are controlling us. So it's a bit of a pessimistic view, but I really believe that at some point in time, AI would be capable of really going onto the super intelligence level and really controlling our world if we're not careful. And maybe this is why we have this podcast, because we really don't want AIs to go rogue and go deviance. So have you played the game Detroit Become Human?
No, I have not.
Well, you're missing a lot. It actually talks about this. It actually talks about sentience. So it talks about that we have like robot servants and so on, and they actually become conscious and they don't follow the rules any longer, and they're not obedient to us anymore. And then they go rogue and they want to have like equal rights, and it's a beautiful game. You should play it.
Yeah, I definitely will consider that. And yeah, that would be a fascinating world. See, I don't know. Like I'm always of the view that never say never.
Yep.
But from what I've read, and I am no expert on human consciousness or consciousness in general, but from whatever hobby reading I've come across, like my current opinion is that it seems that consciousness is an artifact of a biological system, and the way we've structured our technology, it is in fact very, very structured. So that is a bit of a disappointing point of view if you think about it, but maybe not. Like you get to know what you're doing, you get to see the advancements, and there are so many people working on this, so many people just trying to accomplish the simplest of things, understanding how people see things differently, how your emotions affect your decision making. We are very complex human beings, and we're aiming to build machines that mimic this complexity. And I think there's still
hope for
a ways to go.
Hope for the machines to become aware and
perhaps maybe
and come alive.
Maybe.
Yeah, maybe. So Salem, it's a real pleasure to have you today, and let me tell you a little bit about why we're here today and what we're trying to do with this with these discussions. So in the past 5 to 6 years, many companies have been experimenting and playing around with AI. And of course, AI was all the buzz in every industry.
Yeah.
And it's not coming from vanity. It's really when a company really adopts artificial intelligence, it can access incredible operation scalability. It can create a really differentiated customer experience, and it can. So, Nick Bostrom, one of them, he's the author of the book Super Intelligence. This is why we were talking about super intelligence and so on. And he talks about that there is an announced arms race between all countries to really reach AI superiority. And he speaks about that when a country reaches AI superiority, it's exactly like when the United States have reached the nuclear weapon in 1945. So it's really, so the technology itself can really create a great competitive advantage to any organization that adopts it. So in the past 5 to 6 years, companies have been experimenting. They were trying to build the capabilities of building AI and trying to really understand the technology. Now I think the industry itself has matured a lot, and it feels like everyone is at a starting line and someone is about to fire a gun, and everyone would launch their AIs into market, and everyone is racing to ship as many models as possible to market and so on. Though there is a lot to really that we have to understand when it comes to actually managing AI in operations. And of course, so things like, for example, running AI in a compliant way, really understanding that AI is not biased. It's not, being like favor, basically, casting away any group of people and really benefiting another group. So all of these things are some of the things that the AI community is really concerned about and are really actively working on making sure that these things never happen. Of course, one of the core principles of running AI in operations is explainability. So you're an expert on the subject, and this is why you're here today. So would you please give the audience a little bit about yourself, what you're doing, and how did the world throw you in the explainability field, and why is this interesting? Why is this important?
So the beginning of my introduction to the world of explainability essentially comes from a slightly adjacent field, and that in statistics is variable selection. So a little bit about myself. I am a PhD candidate majoring in statistics, and my work is mostly about variable selection in high dimensional data settings. In plain English, what that means
Please
is...
explain that.
Yeah, definitely. So it's when you have many features, covariates, characteristics. It's whatever you feed your model with in an AI setting. So for people who like computer vision, for example, when you work with images, you can consider each pixel to be one of these covariates or one of these features that go into the model. And naturally, everyone, of course, knows this. We're generating way more data now than ever before. And it's increasing at an exponential rate. So what we aim to do with variable selection is that when you have so much data, so many factors that can be what you're looking for, we want to essentially narrow it down to the things that really matter. That is one prime example of this is when you're looking at genome data. You have like these hundreds of thousands of genes. You want to understand which genes like contribute to a specific disease, specific health condition, and you're just dealing with so many, and you may not have a lot of observations. You may just have like maybe 30 people come in and get tested, and you have all these potential contributing factors. So going back to the idea of explainability, one core thing about, or one defining feature of AI, of course, is like its foundational block, the neural network. In short, the neural network is a very flexible model. Of course, that depends on the size of the neural network, and we're talking, of course, deep learning. But it is a very flexible model, essentially, that can adapt to whatever data you feed into it. That's why it can be used for tabular data, image data, videos. I mean, you at Synapse do a lot of work with neural networks, definitely a lot of products based on neural networks. And so what we have here with a very flexible model is that it's going to fit any situation regardless. It's flexible enough. And it is what we call, in fact, a black box model, meaning that you just give it input and it gives you output that matches your input really well. So you don't really know what's going on in this black box model. And so let me just close or restrict like the scope of this question by answering why explainability is important. So explainability grants you a few things which its lack can really hurt. So one of these is something that you mentioned, bias. I don't know if you've heard of this, but there have been quite a few incidents with bias, specifically when you train some models on data from certain races or from certain groups of people. It really doesn't generalize well to other groups. And so that's I think we'll talk about like the rest of the points.
Yes.
But yeah, I think it's a good lead and a very long intro into how I got into model explainability.
So you said more than a few terms here that I think it's are really important. For instance, the term generalizable enough. So building, of course, a generalizable enough model is really important. So can you shed a little bit of light on what is a generalizable model or what is a robust model, and why is it important to have these models?
Yeah, I think generalizability is a very broad term, and you, as someone who does actually work in the business, probably deal with that a lot more than I do. So in terms of generalizability, what I was referring to earlier is generalizing from one specific group or like one specific data set to data that has not been seen before by your AI, by your product. That's the kind of generalizability I was referring to. But there are definitely other kinds, and one of them is whether a model can generalize to different tasks. So a model that can, let's say, identify animals in a picture, can it also identify maybe hair color of humans in the picture? So that's when you have a model that can do multiple tasks all at once. But I think you definitely have a few other definitions of generalizability.
Yeah, it's so when you speak really about generalizable model in the business, we usually mean so when we're trying to really release an AI into the market, it's of course we're trying to compromise accuracy for coverage and vice versa. So we're basically want to achieve we want our model to be as accurate as possible, and it would cover as many of the population as we can. So we don't want, for example, to have a model that is really accurate on the Sheikh Zayed inhabitants, and not really work on Mansoura people who are living there, and it's not accurate at all with them. So this is what we try to achieve. And I think you spoke a little bit about the general general AI, and not so usually there is a difference in the field between narrow AI, where an AI, as you said, can really differentiate between a dog and a cat, and there is the general AI that really can identify a dog and a cat, a cupcake and an apple, hair color, and all of this and all of that stuff. So it's really an AI that is capable of doing more than one thing. Now, let's get back to explainability. What really provoked your interest into dedicating your PhD to researching explainability and really going deeper and deeper into that subject?
So there are a few reasons, and I think the most important of these is that so far the progress of AI has largely depended on the progress in terms of computational power, our progress. our technological progress in terms of computational power. Models are growing in the number of parameters. We have models that have billions of parameters these days. Personally, that's not a very interesting way to grow, in my opinion. Just adding more parameters and brute force computing things. What attracted me to variable selection and model explainability is that you try to identify the things that really matter. So you can build more sparse models, models that are not as computationally intense, but that perform as well as this very huge model we're comparing to, and having a smaller model, or I would like to say a sleeker model, is it helps with understanding what features or what factors are contributing to the output that you're seeing. And also, back to your earlier discussion about superintelligence, I think that is closer to the way human beings operate, is that you have certain points of focus, certain things that you look at, probably in combination with other priors that you learn from your general experiences in life.
Yeah.
And that is how your decision-making process proceeds.
Yeah. So when you're explaining neural networks, you said that they are what's categorized as black box models. So as opposed to what? So is there like anything other than black box models?
Yeah. So I would say the antonym of that is glass box models. Some people call it glass box models. And of course, like the two terms, what they reflect is the transparency, how interpretable a model is, how explainable it is. There's like a fine difference between those, but there, like the line is very blurred between interpretability and explainability. But the core idea here is that you can have a quote-unquote glass model that is transparent, that you know what's going on inside. You know the workings of the model. Like the typical example of that is a linear regression. A linear regression has assumptions. You restrict your model to only building a linear plane. That means, in simpler terms, if you're looking at two variables, it means I want you to draw the best line going on there. Black box models have a lot more flexibility, and they're not usually as well defined. Taking again, the most extreme example of that is the deep neural network. What you have is something that is extremely flexible, that can model almost any, like not almost, it can model any functional relationship. You don't know what's going on because it just has so many layers and so many parameters. So you as a human being cannot just look at the structure or look at the equations and say, okay, I know what's going on here. In a deep neural network, I'm not talking like a multi-layer perceptron with two levels, but it's just not understandable or graspable for a human being, as opposed to these simpler models that have more structure. So we have these glass box that you can understand, that you can explain. You know what's going on, if the relationship is like positive, negative. In a neural network, you have your inputs and you have your outputs, and what you know is that it predicts very well.
So there's a mantra. I'm sure it's more of a, I was going to say this is an Egyptian mantra, but I think this is more of a global one. If it works, don't fix it, right? So if the neural network, if your network works fine and it's creating, the required output, it's accurate, it's actually working well. Why is it so important to understand why is it working well? Why not leave it alone and not try to dig into it and really, as you said, really creating an interpretability for the network?
So I think you very wisely also brushed up on that in the beginning. So it depends. It really depends. If all you're trying to do is just predict things, then you may do very well with a black box model. But there are situations where it just wouldn't work for you. And again, like going back to the example of bias, you don't really know the kind of bias that you're going to face with the model because you do not know the model structure. You just know that it works for the data that you had at the time. And of course, then you get stuff like data drift. You just don't know what's going to happen. And that generalizes to a larger class of problems, not just bias, is that you don't really know the weak spots of your model because it's only been tested on what you've seen. It has no structure. So you don't see the areas, like what it does in the areas that it hasn't experienced before. And on a more, so there's a more, again, legal argument for that, is that some of these models are being used, for example, to place people into jobs, predict who's going to do better in a job. And that, again, leads to concerns that the decisions that you make using AI are not defensible. Someone could argue that, hey, you know what, your criteria, just like, what are they? Maybe there's discrimination there. All I'm seeing is that you just put my data into a model and it said no, so I really want to know what's going on here. And I do believe like there are very strict laws about this in some countries where you can't actually use the models due to lack of explainability and interpretability. So these are major concerns there. And of course, it depends, again, going back to the argument of what you want to do. So one typical data science problem is lead generation. I believe you've also worked with that at Synapse.
We worked on a few projects.
So that's so you get a data set and you just predict who's going to be a good lead. But a black box model will not tell you what characteristics in the population will lead to a good lead. It just tells you, it just predicts on
this is a good lead, this is not a good lead.
So you don't know what characteristics you're looking for. You just know that that person that's already in your data set is either going to be or not going to be a good lead. And it doesn't really help with exploration. You don't really learn something. You just can predict stuff really well.
So this creates also, I think, some sort of trust between the model and, because usually the models are built by data scientists and machine learning engineers, and they usually, the customers can be like internal salespeople. And if you don't really provide the salespeople of why this is a good lead, they might not really, work with it, or they might not trust it. And as you know, of course, I now have a daughter, and of course my playlist is full of Disney songs. And I heard this, I think it was a Tarzan song, when Phil Collins says, they just can't trust what they can't explain. So I think it's very relevant here, because I think part of creating trust between AI and humans, the end users of AI, hopefully not the other way around, is to really trust the AI that is in the works, and really understand why it's predicting these predictions. And I really like that you also touch on the data drifts, and so there's also a technical benefit to it as well, for the data scientists to be able to monitor and to diagnose what is happening in their models. So I remember before we agreed on this podcast episode, you were talking to me about feature importance, and I think this is really your focus, right, in your PhD. So what is feature importance? Why is feature importance important? And what is it exactly?
So it's another way, and it's very closely intertwined with explainability and interpretability. So feature importance is, again, about variable selection. In very simple terms, which part of the data is important and which part of the data can you do without. So when you have these really large data sets, you don't want to try everything. You don't just want to try all possible combinations. You want to have a system. You want to have an effective system for picking out what matters, whether it's for the sake of your computational resources, or again, for the sake of explainability, where you only have these limited number of factors to choose from. And that is what feature importance is all about. So we have these, especially for AI, there are many tools for feature importance and both model explainability. Some of these are model specific. Some of these are model agnostic. I know you like that word.
Yeah.
And some of these are global in the sense that they give you an idea of the overall structure in the data of the overall model, what's important in the model.
Yeah.
Some of these are more local. They operate at an individual observation level.
Yeah.
So what these do, again, is that they try to construct some index, or so they give you some number that tell you how important a feature is to the benefit of your model.
Yeah.
Like if you did not have that piece of data, how much would that hurt your model's performance?
Yeah.
This is what feature importance is about. Why is that something difficult? Why is it not obvious? Again, that goes back to the number of features that you often have to examine, as well as the interrelationship between these features. So one feature may be useless without like an accompanying feature that gives it that work together to like greatly increase the predictive power of the model. And so there are many ways to compute or estimate feature importance, and of course, it has a huge impact on what you're doing.
All right, so we're back. We had like a commercial break, or it's not a commercial break. We actually had some technical problems, and the funny thing is that we actually finished the podcast and we finished the episode, but for some reason the camera went rogue and it decided not to not to shoot the video anymore. I think
signs of super intelligence.
Yes, I think we talked. I think we wronged the camera when we talked about machines, and you're not believing in like super intelligence. I think the camera took the wrong way. So please respect the machine. So before we were cut off, Sam, you were saying what is the difference between like what makes the difference between a good data scientist and a great data scientist. So can you please, I'm very sorry, but can you please repeat your point on that?
Yeah, I think so. That's going to be kind of a cliche answer, but it is really what it is. What separates a good data scientist from a great data scientist is that even though they all have to be very technically capable, a great data scientist goes the extra mile and talks to the domain experts. A great data scientist must have excellent communication skills. They need to know which people are in charge of what tasks, who knows what, and how to bring these people together to achieve the right goals, which again, they need to learn via their communication skills.
Yeah. And as someone who served a lot of like business users and they were your customers, really, other than communication skills, I think one of the most important aspects of being a data scientist is not to lose your customer, or not to lose your business user, like in the first 5 minutes of doing a presentation, and then they're completely blocked out and they're looking at their phone, they're WhatsApping, looking at their Instagram. So how do you keep them engaged and during the process, during your design, because they're the end users and you really want them to adopt your model, and it becomes an integral part of their day-to-day. So how do you keep them engaged?
That's exactly the same as how you keep anyone else engaged on any topic, is by focusing on what matters most to them.
Yeah.
And that again involves understanding what matters the most to them, understanding their goals, and understanding what they've tried before, what has worked for them in the past and what has not worked.
Yeah.
Why are you there? Why are they collaborating with you to solve their problem, and what is their problem? So talking about things and framing things in their world, or to put it in a better way, is framing the project or framing the problem in their terms, on their turf, is something that they can relate to. Again, you're there because they want you to be there. You just have to make it so that they want to listen to you, and that you're saying the things that matter the most to them.
Yeah. And all of this can bring us back to the explainability point, right? So
Yes,
when you present them with the solution, if you can provide really a backing of the model, and why is this model working well, and why it will predict the right predictions if you're providing them with real explainability and really showing them. So sometimes actually one of the things is that if you show them like a feature importance visual of some kind, they can really understand better about their business. They really can understand better about their consumers, how their customers, what is the most important thing about for their customers, for example. So really explainability, we come back to explainability and why is it important for the data scientists to have their model adopted by the business. So Sam, I have to ask you this. So what is the most intriguing, what is the most interesting thing for you right now in the AI? Have you seen the DAL-E thing from OpenAI?
Yeah, just a few days ago, actually.
Yeah, it's incredible. So for those who don't know it, so it's DAL, DALL.E, and it's an initiative from OpenAI where you just write like a phrase, and for example, a chimpanzee riding a motorcycle, and then it can create a real image of a chimpanzee riding a motorcycle. So it's incredible, and this is what I love about the field, that really, other than all the very, very serious stuff about AI and compliance and so on, you can actually play with it, and it's a really playful technology. You can do with it a lot. So what really excites you about it? What is the most what piques your interest in the field right now?
So right now, I would say it's the race for having more efficient, sleeker AI models. So a lot of research right now is about how we can make these AI models understand, or at least be able to extract whole constructs, whole concepts from the data. That is something that we as humans can do, but AI has not gotten there yet. AI treats like each data point as its own, or like not data point, each piece of information as its own, like I would say, item. But what's going on right now is that people are trying to build AI that not necessarily understands constructs, but knows how to extract them from the data, and how to, in a sense, again, produce explainable output. I think that is a step, a major step towards achieving something that is similar to kind of like the way we humans think, maybe a step towards super intelligence. So that is something that I do find to be very fascinating. And I think it's going to be pretty soon that we're going to have very different AI models than the ones we have now, ones that are more optimized, ones that more closely resemble a human being's thought process, or at least can be framed in terms of human beings' thought process.
So this makes me feel a little bit bad about me becoming very, very excited about the chimpanzee riding a motorcycle, because after your answer, it makes my excitement about the DAL-E.
Yours is cooler.
Salem, it was an absolute pleasure speaking to you today, and your insights were really incredible. Thank you so much, and really looking forward to our next one.
The pleasure
Thank
was
you
all
so
mine.
much.
Thank you.